The universe shouldn't look like this. Not this ordered, not this stable, not this astonishingly precise. Shift the laws of nature by the tiniest amount, a fraction of a percent, a microscopic tweak in the cosmic code, and stars wouldn't form, atoms wouldn't stay together, and life would be nothing more than a mathematical impossibility. And yet, here we are, breathing, thinking, questioning why everything seems tuned, delicately, almost impossibly, for our existence. This is the mystery of the fine-tuned universe, and it may be the most profound riddle science has ever encountered. Everything in the universe operates under a set of invisible constants, numbers that never change. Gravity, electromagnetism, the mass of electrons and protons, the speed of light, the ultimate speed limit of reality. These values look simple on paper, but they shape everything from the smallest atom to the largest galaxy. Cosmologists say there are over a dozen constants that fall within unbelievably narrow ranges, so narrow that even a tiny deviation would leave the universe sterile and lifeless. It's as if reality is balanced on a cosmic knife edge. A tiny shift to one side, chaos. A tiny shift to the other, nothingness. But why? Why are these constants locked into the only values that allow stars, planets, chemistry, and life to exist? Searching for that answer has become one of the biggest scientific quests of our time. To understand fine-tuning, let's look at how fragile the universe truly is. Gravity is incredibly weak. You can lift a paperclip against the gravitational pull of an entire planet. But this weakness is not a flaw, it's a requirement for life. If gravity was slightly stronger, stars would collapse too quickly and burn out long before life could evolve. If it were weaker, matter wouldn't clump together at all. No galaxies, no stars, no planets. Electromagnetic force. This force makes chemistry possible. If it was slightly weaker, atoms would fall apart. If it was slightly stronger, electrons would cling too tightly to nuclei to form complex molecules. No chemistry, no life. The strong nuclear force. This is the force that holds atomic nuclei together. If it were weaker by just 2%, hydrogen itself would become unstable. If it was slightly stronger, stars couldn't ignite fusion. No starlight, no life, dark energy. Perhaps the strangest constant of all. If dark energy was stronger, the universe would expand too fast for galaxies to form. If weaker, the universe would collapse back into itself. Each of these forces defines a narrow window where life can exist, and somehow, every one of them falls exactly within that window. We often talk about planets being in a Goldilocks zone, not too hot, not too cold. But what if the entire universe is in its own Goldilocks zone? The expansion rate of the Big Bang, the density of matter, the ratio of photons to baryons, the balance between matter and antimatter. Every one of these values pass through a razor-thin corridor of possibility. Scientists calculated that if the expansion rate of the early universe had been faster by 1 part in 10 trillion, galaxies would never have formed. If slower, the universe would have collapsed within seconds. This doesn't look like coincidence. It looks like precision, as if nature drew a thin line between life and oblivion, and the universe followed it perfectly. Which leads to a provocative question. Is this fine-tuning real, or is our perspective creating the illusion? One explanation scientists suggest is the Anthropic Principle. It argues, the universe appears fine-tuned for life because we are in a universe where life is possible. If it weren't possible, we wouldn't be here to notice. It's logically correct, but emotionally and scientifically unsatisfying. It's like waking up on a perfect island and saying, "This island supports life because I'm alive on it." True, but why is the island perfect in the first place? The Anthropic Principle describes the situation, but it doesn't explain it. So scientists turned to a far more dramatic idea. What if our universe is just one among many? Millions, billions, maybe an infinite number of universes, each with different laws, different constants, different outcomes. In most universes, stars never ignite. Matter collapses instantly. Physics becomes too chaotic for anything stable to exist. But in a tiny fraction, perhaps 1 in a trillion, the constants fall into the narrow band that allows chemistry, complexity, and life. If that's true, then we exist simply because we're in the one universe where life can exist. We won the cosmic lottery. We're not special, we're just possible. But here's the problem. If other universes exist, we cannot see them. We cannot measure them. We cannot prove they're real. So, is the multiverse an explanation or an elegant escape hatch for a mystery we don't yet understand? Some physicists believe fine-tuning hints at deeper, undiscovered laws of nature. Maybe these constants are not arbitrary at all. Maybe they had to be exactly what they are. Others see fine-tuning as a kind of design, not necessarily by a conscious creator, but by mathematical inevitability, or a universe that naturally selects complexity. And still others think the entire discussion is premature, that future physics may show these constants are obvious and unavoidable. The truth is simple. We don't know. Not yet. Fine-tuning sits at the boundary, where science fades into philosophy, a place where our deepest questions wait for answers. Here is what we can say. If the laws of the universe were even slightly different, you wouldn't be watching this. Stars wouldn't shine. Atoms wouldn't form. Life would be impossible. The universe is balanced on a razor's edge, and somehow we exist exactly on that edge. So what does that mean? A coincidence? A necessity? A cosmic accident? Or the signature of something deeper? There is still so much left to uncover.